Hello again, and welcome to our next module on clean architecture. I'm Matthew Renzi with Pluralsight, and in this module, we'll learn about domain-centric architecture. As an overview of this module, first, we'll learn about domain-centric architecture and how it differs from database-centric architecture. Next, we'll learn about three types of domain-centric architectures. Then, we'll learn about the pros and cons of implementing a domain-centric architecture. Finally, we'll see a demo of our domain-centric demo application. So let's get started. We all know that the Earth is at the center of the solar system, and that the Sun, the Moon, and the planets revolve around the Earth, correct? Well, they don't anymore, but they did at one time. However, a very smart guy by the name of Nicholas Copernicus changed the way we look at our solar system. Rather than assuming that the Earth was at the center of the solar system, old Nick had this crazy idea that the Sun might be at the center of our solar system instead. This shift in perspective turned out to produce a better model of the solar system in the sense that it's both simpler and yet it provides more explanatory power. It's essentially a more elegant model of our solar system. A similar shift in thinking is happening in the world of software architecture as we speak. Here, we have the classic three-layer database-centric architecture. Its key feature is that the user interface, business logic, and data access layer revolve around the database. The database is essential, and thus it's at the center of this architecture. However, a new perspective has changed the way many of us look at our architecture. Rather than having the database at the center of our architecture, some of us are putting the domain at the center and making the database just an implementation detail outside of the architecture. Here, the domain is essential and the database is just a detail. So why has this happened? I think this change in perspective is best summed up by a quote from Robert C. Martin, better known in the software industry as Uncle Bob. He says, "The first concern of the architect is to make sure that the house is usable. It is not to ensure that the house is made of brick." This change in architectural perspective is being caused by a change in perspective about what is essential in an architecture versus what is just an implementation detail. Using our building architecture metaphor, when we're building a house, what is essential versus what is a detail? The space inside of a house is essential. Without empty space to inhabit, the house would serve no purpose. The usability of the house is essential. If the house didn't contain rooms and features to support our primary needs, again, the house would not serve its purpose. However, the building material is just an implementation detail. We could build it out of brick, stone, wood, or many other materials. In addition, the ornamentation is just a detail. We could still live in this house whether it had Victorian molding, gold trim, French doors, or no ornamentation at all. The things that are essential in a house are so because they support the primary needs of the inhabitants of the house. Everything else is just an implementation detail. In clean architecture, the same holds true. What is essential are the things that support the primary needs of the inhabitants of the architecture. The domain model is essential. Without it, the system would not represent the mental models of the users. The use cases are essential. Without them, the system would not solve the user's problems. However, the presentation is just a detail. We can deliver the UI in web forms, ASP.NET MVC, or as a single-page JavaScript application. And the persistence is just a detail. We can store the data in a relational database, NoSQL database, or as plain old JSON files. Now, don't get me wrong, the presentation and persistence technologies are very important. They are just not essential to solving the problem that the user is attempting to solve with the application. Once we've changed our perspective about what is essential versus what is a detail in software architecture, we can start to see why a transition from database-centric architecture to domain-centric architecture is occurring. With database-centric architectures, the database is essential, so the database is at the center of the application, and all dependencies point towards the database. With domain-centric architectures, the domain and use cases are essential, and the presentation and persistence are just a detail. So the domain is at the center of the application, wrapped in an application layer, and all dependencies point towards the domain. So now let's take a look at a few types of domain-centric architectures. First, we have Alistair Coburn's Hexagonal Architecture. It's a layered architecture with the application layer and thus transitively the domain at the center of the architecture. In addition, it's a plug-in architecture which includes ports and adapters. Essentially, the outer layers of the architecture are adapting the inner application layer to the various presentation mediums, persistence mediums, and external systems. You can run and thus test in isolation this entire application architecture without a UI, a database, or any external dependencies. Next, we have the Onion Architecture by Jeffrey Palermo. This is also a layered architecture with the domain at the center surrounded by an application layer. The outer layers consist of a thin UI as a presentation layer and an infrastructure layer which includes persistence. In addition, all dependencies point towards the center of the architecture, that is, no inner layer knows about any outer layer. Once again, you can test this application architecture in isolation without a UI, a database, or any external dependencies. Finally, we have the Clean Architecture by Uncle Bob. Once again, it's a layered architecture with the domain, that is the entities, at the center surrounded by an application layer, that is the use cases. The outer layer consists of ports and adapters adapting the application core to the external dependencies via controllers, gateways, and presenters. In addition, Uncle Bob goes one step further by incorporating Ivar Jakobsen's BCE architecture pattern to explain how the presentation layer and the application layer should be wired up. All three of these architectures have roughly the same benefits. However, as Mark Seaman has pointed out, all of these domain-centric architectures are essentially just focusing on different aspects of the same key set of ideas. Essentially, they all put the domain model at the center, wrap it in an application layer which embeds the use cases, adapts the application to the implementation details, and all dependencies should point inwards towards the domain. So why would we want to use a domain-centric architecture? First, focus is placed on the domain, which is essential to the inhabitants of the architecture, that is, the users and the developers, which, as we've learned in the previous module, provides several benefits and cost reductions for our software. Second, there is less coupling between the domain logic and the implementation details, for example, the presentation, database, and operating system. This allows a system to be more flexible and adaptable, and we can much more easily evolve the architecture over time. Third, using a domain-centric architecture allows us to incorporate domain-driven design, which is a great set of strategies by Eric Evans for handling business domains with a high degree of complexity. However, that's an entire course on its own, but I'll show you where to go to learn more at the end of this course. So why would we not want to use a domain-centric architecture? First, change is difficult. Most developers come out of college having only been taught the traditional three-layer database-centric architecture. In addition, it may also be the only architectural model that the architect knows well enough to offer guidance on. Second, it requires more thought to implement a domain-centric design. You need to know what classes belong in the domain layer and what classes belong in the application layer, rather than just throwing everything in a business logic layer. Third, it has a higher initial cost to implement this architecture compared to a traditional three-layer database-centric architecture. However, it typically pays itself off if the application is complex enough and has a long enough life cycle, which is the case with most modern applications these days. Now let's see a demo of a domain-centric architecture in action. Now let's take a look at a domain-centric architecture in action. It's important to note that I've created the simplest domain possible to communicate these architectural ideas. In most modern applications, the domain model would be significantly more complex than this. While I personally prefer to use more powerful domain modeling techniques like domain-driven design and event sourcing for dealing with complex domains, right now we're just interested in learning the basics. So a more complex domain with more advanced domain-centric practices will just get in the way of learning. However, I'll point you in the direction of additional information so you can learn these more advanced domain modeling practices at the end of this course. Let's begin by looking at a graph of the project dependencies in our solution. We're just going to focus on the most important projects and compile time project references to keep things simple for now. Starting at the top, we have our presentation project. It has a dependency on the application project and thus transitively an indirect dependency on the domain via the application project. Next, we have the application project itself. This project has a direct dependency on the domain project. Then we have the persistence project. It has an indirect dependency on the domain via the application project and a direct dependency on the domain via project reference as well. This direct dependency is necessary because we're using Microsoft Entity Framework to map our domain entities to our database tables. This direct dependency isn't necessary in general for clean architecture. However, it is necessary in this case in order to use Entity Framework as our object relational mapper. Finally, we have the infrastructure project. It has an indirect dependency on the domain via the application project. The key idea here is that the domain is at the center of the architecture, and all dependencies point either directly or indirectly towards the domain. Now let's take a look at our domain project. We organize our folders, classes, and namespaces via a concept we refer to as functional cohesion, which we'll discuss in a later module. For the time being, it's easiest to say that we're organizing things by the key entities in our domain. In domain-driven design, we more precisely refer to these as the aggregate root entities in our domain model. That is, the topmost entities with persistent identity in a graph of dependent entities and value objects. Each of these folders contains the aggregate root that the folder is named after. For example, customers, employees, products, and sales, and any domain entities, value objects, or domain services that these entities depend upon. In addition, we have a common folder for classes and interfaces that are shared between the aggregate roots. For example, the iEntity interface, which allows all entities to be worked with generically as objects with persistent identity. That is, they each have a unique identifier. Finally, let's take a look at the sale class. As I mentioned before, I'm trying to keep things simple, so we aren't using a rich domain model or concepts like parent-child entity relationships, value objects, or domain services like we would be using with domain-driven design or event sourcing. In addition, if we were using domain-driven design, we'd have classes with methods corresponding to actions named in the language of the business, rather than the relatively anemic domain model composed of mostly property getters and setters, which I'm using for simplicity's sake. Also, if we were using event sourcing, we'd be applying events to our domain entities to modify their state, rather than simply calling property getters and setters. As we can see, this class implements the iEntity interface so that it can be used generically like all of the entities in our domain. At the top of the class, we have private fields which contain data for our class. Next, we have the auto-implemented properties for this class. These store data without requiring backing fields like the private fields above. Some of these store primitive data types and data structures like ID and date, while others store references to entities like customer, employee, and product. Below this, we have property getters and setters for the properties that use backing fields and logic within the setters. For example, unit price and quantity. These setters have logic in order to update the total price property so that it reflects the total price given the unit price and quantity of products sold. Finally, we have a private method called updateTotalPrice, which executes the domain logic to update the total price of the sale. As we can see, we've kept the domain logic and code very simple so that we can focus on architectural practices rather than deal with a complex domain during our code demos. What's important to note for this demo is that our domain project contains our domain model, which is an abstract representation of the business problem being solved. All of our classes, properties, and methods should correspond to concepts that exist in the business world in the language of the business. In addition, ideally, there should be no abstraction leakage. That is, there shouldn't be any classes, attributes, or aspects in our domain model that pertain to the implementation details of the application. Details like persistence, infrastructure, or presentation. So now that we've seen what a simple domain model looks like in domain-centric architecture, we can focus on the other important aspects of a clean architecture. In this module, first, we learned about domain-centric architecture and how it differs from database-centric architecture. Next, we learned about 3 types of domain-centric architectures. Then, we learned about the pros and cons of implementing a domain-centric architecture. Finally, we saw a demo of our domain-centric demo application. In the next module, we'll learn about the application layer and why we may or may not want to implement an application layer in our architecture.